This is just a summary of what we saw in the pure product right out of the pail. The PAHs and the coal tar sealants were 1,000 times higher in concentration than the asphalt sealants. In the runoff samples, the coal tar sealants were 6 times higher than the asphalt sealants. The scrapings that we scraped right off the parking lot, the PAH concentrations were 30 times higher than they were in the asphalt sealants. And the load, that's the actual volume of PAHs coming off these, were twice as high in the coal tar products than the asphalt products. So we started to do some biological studies, and we did 3 different types of biological studies. We did a lab toxicity test, we did something called a microcosm, and we did a field study. And let me tell you just real quickly about those tests and what the results were. The first that we did was a standard lab toxicity test. We put standard test organisms, the kind of aquatic invertebrates that people look at all the time to study toxicity. And we spiked sediments with the products themselves at 3 levels, low, medium, and high. And these were concentrations that we do, in fact, see in our own stream sediments here in Austin. So we were trying to test some of the situations that we're actually seeing in nature out there. We did both types of products, coal tar products and asphalt products. The first 2 bars that you see there are the controls. Those were sediment. Those were the experiments where we didn't spike. We didn't put any of the contaminants in there. And you can see we got 100% survival of the organisms in those controls. That's what you want. At the very low concentrations, and that concentration is one that we see in about 13% of Austin streams, we lost. On the y-axis there is survival. So about 80%, 81% survived. At the medium concentration, again I'm talking about the blue bar with the coal tar, 29% survived, and at the high concentration only 13% survived. When we used the very same amount of the asphalt-based products, you can see the survivorship was 98%, 95%, and 94%. Pretty darn good relative to the impact of the asphalt on the organisms. We also did the same, what we did was use the very same study then and expose those same organisms in the test think of them as aquariums, I guess, to sunlight to mimic a more natural situation, and also because we know UV light does affect the toxicity of PAHs. And you can see that at that point, when you had UV light added, that we also did start to get toxicity from the asphalt-based products. Even at the very low concentration, we lost 90% of the organisms in the coal tar plot. In the medium and the high concentrations, there weren't enough organisms left over. They had already died in the first run of the experiment. So that's your just lab toxicity, and that tells us what happens to individuals. But we wanted to also understand what happens to the whole aquatic community, all the different types of invertebrates and worms and bugs and things that live in the sediments in Austin. And so we did 2 other types of studies. One of them was this microcosm study where we did the same sort of spiking sediments with contaminants at 3 different levels. But in these, we put the sediment and we also loaded these things with the community of the organisms that live in our streams around Austin. And then after the period of time was over, we took it out and saw what had happened to those communities. We also did a field study where we identified areas where sealed parking lots were draining immediately, were immediately adjacent to streams and drain right into streams. And we went into the stream, collected the organisms, and looked at the community there, and then compared it to what that community of organisms looked like immediately upstream of the drainage from the parking lot. The first, coal tar sealants are indeed significantly toxic to aquatic organisms. And from the last 2 studies that I described, we found that the coal tar sealants did indeed degrade the local aquatic communities. It resulted in a decline in diversity, the numbers of species. It resulted in a decline in abundance. And it resulted in a loss of sensitive species, those species that are intolerant to pollution. Some support for the ban. Just want you to know that 600,000 gallons of coal tar sealant are applied annually in the Austin area. That's equivalent to 4 million pounds of PAHs. The collaborative work that we did with USGS, the calculations that USGS did indicate that the sealants may represent a majority of the pH load in streams studied. And the USGS representative is here. She can explain that work if you want to get into that detail. Also, concentrations of PAHs are increasing. Again, we have found in 13% of Austin streams hot spots that are higher than that concentration where you expect to see impacts to aquatic life. And concentrations of PAHs are increasing dramatically in town. What would the economic impact be of banning these products? I think we're lucky in this case because those impacts would be mitigated by the fact that we have available a less toxic alternative, the asphalt-based sealants. There is no significant difference in the price of these alternatives, although, as I understand it, the prices vary from time to time with the cost of petroleum and other constituents in the products. Many producers make both coal tar and asphalt-based sealants. They make both types of products, and they can switch from one type of product to the next. We do understand, industry folks have told us that the asphalt-based sealants are less durable and that the black color of these products fade. And that is the way in which they are considered to be inferior to the coal tar sealants. However, our local producer who, back when we passed the voluntary ban, started to switch to making more and more of the asphalt-based sealants and less of the coal tar sealants. The warranty that they have on their products is the same, 2 years for both types of products. And my comment on the color is that if the things fade and turn gray instead of black, for those of us who are thinking about urban heat island issues, for me that's a positive thing. We also know from working with the industry folks is that there are emerging pavement sealer products that may offer us even more protection and very low to no PAHs. And so we're pretty excited about the new technology that is coming up in this industry. In summary, PAHs are a very high-profile pollutant of growing concern nationwide. The concentration, the increases that I showed you in Town Lake are mirrored across the country wherever these PAHs are being tracked over time. This research has really unearthed a major new source of PAHs, and the exciting thing for us in the watershed protection area is that most pollutants are extremely difficult to control. Sometimes they're simply things that we can't control, the PAHs that we get from automobile emissions as an example. This one is controllable. It's not mandatory. We don't have to do away with cars, and we have an alternative. And so it represents a very exciting opportunity to make a significant improvement with a single act. We think that the combination of data that we have provided here for you, the chemical tracing, the laboratory toxicity, and our field studies provide ample evidence for you to take this action at this time. So I thank you very much.